This week's episode of the AWS Developers Podcast is recorded in Berlin at the Jamf Live Nation conference, and we are going to talk about spatial computing. Stay tuned. Good morning, good afternoon. Thank you for joining us in a new episode of the weekly AWS Developers Podcast. All things developers, all things AWS in roughly 30 minutes every Friday morning in your podcast application. This week, as I said in the introduction, we are live from Berlin. We are partnering with a company called Jamf, which is known for device management in the cloud, endpoint protection management. That's basically the tools that allows you to manage Mac and iOS devices in enterprise. And on the AWS booth at this conference, I had the pleasure to meet Peter Daukintis. I hope I pronounce your name correctly.
It's actually Daukintis.
Daukintis, thank you. Peter, you're part of the prototyping team at AWS, and you're focalizing your expert in spatial computing. What is spatial computing?
Spatial computing, really to me, is anything with a 3D coordinate. So anything that happens in 3D space. So imagine today that, predominantly we sort of look at computing through glass screens. Right, which is in two dimensions. Now, if we use technologies such as immersive computing, VR, AR, and those kinds of things, we can extend that out into spatial computing with a 3D coordinate, which is much more natural and gives you the opportunity to bring in, natural gestures, eye movements, and all these kinds of things. So you're actually inside your computing space.
So it's any type of application that runs on these fancy devices that are like big glasses. I'm thinking about the Oculus, obviously, but also the Vision Pro from Apple. That's this category of device we're talking about?
Well, that's part of it. I mean, I always think of the end device as maybe the tip of the iceberg. And of course, it's very hard to build any kind of useful application really with just the tip of the iceberg, I would say.
So what other devices are there available on the market today?
So it's kind of, it's interesting to watch how these things have evolved over time. So I did a lot of work with HoloLens, for instance, where, you look through to the real world and really you have digital content, holograms, which are mixed in with the real world. And then traditionally alongside those things, we would have traditional VR, such as, like a Meta Quest or an Oculus device, where you're completely closed in. Everything you see exists only in the memory of a computer. Now, what we're seeing as we move forward is an evolution of those things. So now if we look at Apple Vision Pro, and we look at Meta Quest 3 and Meta Quest Pro, then these are mixed reality devices, but they operate by taking an RGB camera feed from their external location environment, and they sort of stitch those things together such that the user is within their real environment. So it sounds a bit strange because you're taking a camera feed and you're looking at it. To see the real world, you're looking at this camera feed.
So I see the real world through a camera feed, so I have the impression I'm in my living room, but on top of that I can see applications and 3D objects and manipulate objects in that 3D space.
Yeah, and of course, once you have that view of the real world, then we can composite. Very effectively, you can composite digital content into that. Whereas, I suppose the disadvantage of doing it the other way, where you can see the real world, and you are compositing 3D models onto the real world, is that you're sort of the blend mode is such that, you can always sort of see through those things to the real world. They don't absolutely look like they're there.
So the virtual reality that everybody was talking about like 2 or 3 years ago, it's just a tiny portion of the much bigger category, spatial computing.
Yeah, so I always think about it as a spectrum of mixed reality. And these devices like the Apple Vision Pro, you can turn a dial and you can go from full virtual reality to full sort of augmented reality or just looking at the real world.
So you have the choice as the user or as the application developer, and that opens the door to many different use cases. What are the use cases for enterprise? Because I can see the use case for entertainment, gaming, watching video. Of course, that's a fantastic type of device to do that. But for our listeners that are working for a large enterprise, if I'm a bank, an insurance, well, I don't know, any other industry, what are the use cases for the enterprise?
Okay, so there's quite a few, and I try to pick out my favourite ones. So if we think about training, education and training, and say we take a manufacturing scenario, if there's anything that is a dangerous or expensive situation that I could be in, say for instance firefighting. So if you're learning how to be a firefighter, it's quite cost effective to use immersive technology to light fires and learn how to put them out, because you don't have to actually light the fires. Or if you want to learn how to maintain mechanics on an oil rig, so that can be quite dangerous, you can learn how to do those things inside an immersive scenario. And there are lots of scenarios that I could come up with whereby that might be cost effective. So another one that springs to mind is working on an expensive engine and learning how to put it together. If you get it wrong, you don't destroy an expensive engine.
So like manipulate 3D pieces together, learn how to assemble them, how to manipulate them. So learning is clearly one use case.
Well, let me just give you another example of the learning for a sec, because this is quite an interesting one to me in that a few years ago I did a learning experience which was related to health. So it was learning how to do a surgery on somebody's knee. So I had a 3D model of a knee with and I had a scalpel in my hand, and I could cut open the knee and I could carry out the procedure on this knee, and I still have now a memory of doing that in 3D, which to me is an advantage. I really felt like I could actually carry out that operation after I'd done it, and I have the memories now. And I think it takes you beyond a level when you're just looking at pictures in a book. You're actually experiencing.
You do it. You're making it yourself. Is there any device now? I'm thinking about that. Do you have any kind of feedback in your hands when you're doing that, like the sensation of pressure, temperature?
There are devices that you can buy as sort of peripherals to that. I can't think of any. I mean, you get feedback from the controller, the haptic feedback. I did try something which was related to teaching surgeons, actually, where you could actually hold a scalpel and it had a sort of force feedback mechanism within it, which made you feel like you were cutting into the sort of flesh that was there.
Any other domains than training?
Yeah, so this one's quite close to me because I worked in the retail sector for a while, and I think there are quite a lot of angles looking at retail which immersive technology can really sort of push forward. So if we take how supermarkets, for instance, are designed and how the shelves are laid out, often those things are done physically. There are companies which print out labels, for instance, and they will often print out a whole series of those labels, and they will put them on a shelf, and they will have folks check that it looks good. So that all of those scenarios can be done in an immersive setting.
So you mean physically working in a store with a headset on to see in augmented reality the labels of the product?
That's exactly
that would be real.
What I'm talking about. So you can design, supermarkets use side of a planogram, which is a very 2D kind of way to do this, but they will then lay out the products on the shelf in an optimum way for the customers to go in and buy them, depending on their demographics and so on. And the way they do this, I worked for a retailer and they had a dummy store, and they would put out physical dummy objects on shelves, and then they would have a questionnaire, and they would have customers come in, they would have a questionnaire, and they would ask questions about their experience. Now, all of that, if you think about it, it's sort of relatively straightforward to replace that physical store with a digital store, and then suddenly You can reconfigure the shelves at will. You can record data from the users. You don't have to rely on their questionnaire. You know where they're looking. There are, in general, eye trackers on these things, and you can even understand to an extent how they're moving and how they move about the store.
Online shopping as well. That's something we know quite well at Amazon, but for me, yes. I guess it's the first use case I'm thinking about.
Yeah, and there are some other use cases, of course. Like, for instance, Amazon have this thing where you can, you can be browsing the Amazon site, and then you have a button which says, bring this into your environment. Have you seen that? Have you used that? So you should try it. It's on your phone. You can go there. Maybe you're looking at a table lamp, for instance, and you can click that button, and that table lamp will give you an augmented reality experience. So you can place the table lamp on your table.
Oh yes, and that works on regular phone right now. You don't need any kind of special device. You see the device you're planning to buy in your specific environment. So you see the dimension and how it fits in terms of colors. And
yeah, absolutely right. And that experience will improve over time. It's pretty good now, but they are becoming, the way that we render these things is improving. Generative AI is helping in those things, and AI is really being used to infuse traditional old rendering techniques to an extent which things are just becoming much more realistic.
It helps also to reduce or to give access to 3D rendering to people that are not necessarily trained to be 3D modelers. I mean, a regular developer can generate 3D models that are pretty good, man.
Yeah, I mean, I don't think that use case has quite come to fruition yet. And of course, with the advent of generative AI to being able to produce video, it doesn't seem too much of a stretch that you could do some photogrammetry on that video and end up with a 3D model. But the processing for those things takes a bit of time, so it's not quite real time. But traditionally, it's been very, very expensive and very time consuming and very difficult to create content.
And where AWS fits into that? We are in the AWS Developers Podcast right now talking about spatial computing. So what's the AWS part of that? Because everything we said so far is mostly like a client on device experience. What's the backend?
Well, we've been talking about, as I said at the outset, we've been talking about the tip of the iceberg, really. Now, if you want to build any kind of real application, you need the rest of the iceberg. And that iceberg needs to be a secure, globally available iceberg.
Oh, that's something I know. So what's your secure, globally available iceberg? So basically what we're saying is that the AWS cloud is a perfect place to store the backend part of a spatial application. And in that way, spatial application is not very different than a mobile application or a web application, is it?
I would say that's not entirely true. I mean, if you look at back over the history of the 3D industry, there has been a real lack of standardization. There's lots of different file formats that exist in the wild. There's CAD formats, there's meshes, different kind of mesh formats, and a lot of them are proprietary, but they're in wide use. So we can take FBX files as an example of that. It's a proprietary 3D format. And that was actually, I remember when that was first actually conceived, I was working with a company in Canada called Kadara, and they produced a product called Filmbox, hence .fbx. So it was their format that they created in the first place. Now, due to a lack of any accepted other standard, that sort of became quite widely used because it had a full scene description within. Now, that's all well and good, but because it's a proprietary kind of standard, everybody implemented it in a sort of slightly different way. So nothing really ended up being very interoperable. And over the last, say, 3 or 4 years, there have been moves to standardize, should we say. So to begin with, to standardize how things look when they're rendered, and then to standardize how they are transmitted between people and how they are shared and how they're worked on. We're some way down that line, and that scenario is now improving.
So what we are talking about right now, it's a file format to represent 3D object, which is one of the basic building blocks of a 3D or spatial application. We need to have a 3D model of a chair, of a dress, of anything, so that we can see it in our 3D environment. It's like a GIF file, but in 3D. I saw that Pixar was very active in that domain. Is it Pixar or Disney?
Yeah, Pixar came up with the idea of USD. And working on feature films, they have built in all the things you need to be able to do a feature film with a content pipeline. Now, to some extent, we now have another format. So it's like that sort of old joke. We haven't got enough formats here going on here. So the way that things seem to be panning out is that we have a GLTF file, which is a very good runtime format, and then we have USD, which is a very good sort of sharing and authoring.
So storage and transport over the network.
Yes, to an extent. But the idea that when you look at AWS, the idea that we have here is that you have a spatial data lake. Now, if you think about the concepts of a data lake, it's that you sort of throw in anything in there, right? So you throw in any of these formats, you just throw it in. Whether if it's a point cloud, you throw it in. If it's a mesh, you throw it in. It's sort of stored, and it's versioned, and it's globally available, and it's available via an API. But the important point is that often with these scenarios, you need to be able to transform that data. And what you end up doing, largely if you go around to companies and speak to companies, they'll have some kind of processes that happen internally in their company where they transform this data. So they might go from a CAD model to a VR optimized mesh. And there may be 2 or 3 steps in between, which require proprietary software, and so on, maybe some open source software. But there'll be a process. Let
me try to wrap up and to catch up with you to be sure I understand well. So what you're saying is that for application developers that are in the spatial space or spatial computing area, they need to manipulate 3D objects, and there are multiple file formats and rendering formats that are different, probably per device, depending on the vendor of the device. And what enterprises are doing right now, they are building internal data lake with all these objects they need in their application, with the ability to store, to catalog, to retrieve these objects, but also to transform from one format to the other. A bit like Amazon Video Prime is storing different format of the video, depending if you're looking at to the video on an iOS or iPad, you will not receive the same stream. That's the same idea, but at a much larger scale, probably in terms of the number of objects to manage. And is this 3D data lake a service from AWS or something customers are building on top of the building blocks from AWS?
So it's not a service. So we use it in my prototyping team as and in the spatial computing at AWS in general, as a way to be able to deploy these services in such a way that they can be used as a content repository.
Okay, so the customer for that data lake are the developers of the spatial apps. Did I understand correctly?
Yes, that's correct.
Yeah, I got it. But if I zoom out just a bit, I start saying that building a spatial app is not very different than building a mobile application or a website. You still need authentication, you still need, REST API, GraphQL API, and that's the part that I hope developers that are listening to us knows about. With AWS, we can use AWS Amplify, for example, to manage all these aspects of traditional computing. And on top of that, and that's probably the difficulties for more, or the challenge for the majority of the developer, including myself, is to learn about these 3D techniques, rendering, framework, file format. What are the challenge for the traditional mobile application developer to move to the spatial area?
I think the main challenge is there's lots of different technologies which come together that you need to sort of learn in order to be able to produce a full end-to-end app. From learning how the content works, to be able to learning the programming languages that are required, to learning the game engines, to learning the web enablers for this. So my recommendation would be to pick a path through that, as narrow a path as you can. So one example might be, I'm going to learn WebGL. and then I'll learn how to put graphics on the web. And that's one thing you can really focus on and learn. And for that, maybe you need to learn a bit of JavaScript, you need to learn a bit of how 3D content works, and then obviously you need to learn the graphics API around WebGL. That's a self-contained way to build something that you can see. Another way might be using a game engine. So for example, Unity or Unreal Engine or Godot or something like that. And they're quite encapsulated in a lot of respects, because they include the programming language in order to be able to produce sort of interactivity. You'd have to learn about the content, and you'd have to sort of learn how those engines are used to make a game. And if you are building, say, an enterprise app, often a game engine is like using a sledgehammer to crack a nut, honestly. So I think to find a very narrow path through that you can learn and get something on the screen.
What are the typical competencies that we need in a development team? We're mostly talking to enterprise developers here. I guess it's a team made of different talents to create a good spatial app, like traditional developer, 3D modelers, maybe game designer. What are the typical profiles you see for successful app development?
So the way that I think about it, and this, this is just my opinion here, but we'd have a team very similar to a game design team. So we'd have some programmers, we'd have some artists. So those folks, obviously, what they do is pretty clear. But also you need to have those enterprise skills. So there's no way around it. There has to be some cross-contamination of these worlds. So gaming on one side and the enterprise on the other. Traditionally, people that don't often be found together in the bar. I don't know.
But all the skills I have about enterprise computing, like security, authentication, DevOps, or building a CI pipeline, they all apply.
Yes, absolutely. But they apply to the lower part of the iceberg. So the upper part that is that team that I talk about with 3D, because it's you can make people sick with a VR experience if you get the optimization wrong.
Like motion sick.
Like motion sickness, yeah. So if it's dropping frames or the frame rate goes down, it's not stable. And there's a whole skill around writing shaders and optimizing 3D meshes, which somebody has to know those skills.
And these people typically in enterprise are coming or are recruited from the 3D design, the gaming world?
Traditionally, they would be gaming people, yeah.
At the beginning, you said that there are multiple competing platforms with different standards. It sounds familiar to me. I used to develop on mobile application. Right now, still today, developers have to make a choice. Native iOS, native Android, or something in between, like the new Kotlin framework or Flutter. Is it the same with AR, VR?
I'm going to say yes, it is. It's very much the same. When you look at what Meta are doing, they're very much around the web. You look at what Apple are doing with their Vision Pro, that's very much around their technologies and USD. There are some moves to sort of standardize this. And if you look at what NVIDIA are doing around their Omniverse product, that's quite interesting, because they've sort of found a way to have 3D applications interact in real time on the same data. And there's also the Metaverse Standards Forum, who are seeking to be able to standardize these things moving forwards, to be able to sort of, slowly bring the metaverse into being.
Is it too early in the technology life cycle, or is the industry already coming with cross-platform frameworks or development tools? I'm thinking about Flutter, that's the first one that comes to mind, but maybe there is a Flutter equivalent in that space.
Yeah, very much so. So if you look into the web world of rendering 3D graphics, then we have frameworks like Babylon.js, we have 3JS, and really they're right at the top level. So they enable you to load in a 3D model, for instance, and with one line of code create a camera to view that content. If we start going down the stack a little bit, then traditionally OpenGL, many years ago, can't remember when exactly, but OpenGL was ported to WebGL. So it's a sort of subset of OpenGL. which you could use to render 3D graphics in a browser. And that sort of became fairly well used and standardized across all the browsers. As we move forward, we see new advances in that sort of technology. So we now have things like WebGPU, for instance, which is a modern graphics API, which will take the place of WebGL. And we have things like WebXR, which is another standard around immersive devices and so on. And we have OpenXR as well, which enables, and you can see where I'm going with this, that but there is a move to standardize. Sometimes, you can see those things going forward, and I always think about it in terms of the speed it takes features to hit those platforms. And traditionally, it takes a bit longer for web things to hit because you've got the web committees and so on, whereas a company tends to get those things out very quickly to support their devices. So there's always been this, I think this is the true for applications in general, but maybe more so when you've put sort of immersive devices into the mix.
We are here recording this episode this week at a very Apple-centric conference, and Apple released visionOS 6 months ago. A few weeks ago at the .DC conference, they announced visionOS 2. Are they shaking this world, this space of spatial computing? Like the new player, the new kids on the block doing things a bit differently?
I think, for many years it's been anticipated that they were going to release a device and move into this area. So my opinion is that the Apple Vision Pro is a developer kit. It's there. It doesn't really have too many first-party applications on it. It's a blank canvas. My feeling is that Apple have put a lot of energy and work into the development tools. So I think they've said, here's a blank canvas to the developers, and they're waiting to see what comes back. Now, I think as we move forward, we'll see new devices, but assuming that that's successful, we'll see devices with different form factors and so on. And so I think in answer to your question, I didn't really answer it, but it's sort of shaken, it's tremored the industry.
I listen to you talking, and I was thinking, but maybe I'm wrong, that to develop a successful spatial app, that's not something a single person can do. I mean, as a mobile application developer, I can release somehow an application that is okay, but I really need a graphic designer if I want to make the application outstanding, because at least I'm talking for me, I can write code, I cannot design something. And I think that with spatial computing, it's even one step above, one step further. We really need 3D specialists in the team.
Yes, at this point in time, almost certainly. I mean, there is, there's a cross-section of many, many different skills. I mean, I'm quite old, so I've been in the industry for a long time, and it's given me the time to learn those skills. But it has taken me many years to do it.
What would be your advice to developers listening to us and willing to start their first project? Which device, which format, which development tools? Okay, the backend question, it's clear, it's AWS, there is no other. but what about the tip of the iceberg?
So I think, you don't have to have a device, to be honest. So a lot of the device creators have simulators. So if you're in the Apple ecosystem, go and have a look at Apple's tools. You can write an app for Apple Vision Pro using their simulator. And the same thing for HoloLens, so you can go and do that with the Microsoft ecosystem. And the same thing with Meta. So maybe the way into this is just don't make things too difficult, because there's so many things. If there are things that you know already, like you're in the Apple ecosystem, then leverage that and just learn things on top, which enable your sort of spatial skills to grow.
Yeah, my own experience is pretty easy. Any iOS application, you just need to recompile it for visionOS, and you start in the visionOS simulator, and it works. But it's a 2D application in a 3D space. It doesn't bring anything new in terms of user experience. If I want to bring a new user experience, I have really to redesign my applications.
Yeah, but that's a great start, because you know the ecosystem, you know how to deploy an app. So all you need to add on to this is you need to learn how to make the content, or how to get the content, and then how to compile it into a 3D application. And I'm saying only, admittedly, that is not that easy, but if you have to learn all of those things from scratch, including AWS, then that's quite a big ask of any one person.
Yeah, that's for sure. That's the sheep with 5 legs, or the black sheep, knowing the back end, the front end, the 3D part. That's probably too much for one single person.
If I may just mention this, we haven't spoken about digital twins at all, which is quite a large topic in this space.
For me, it fits in another category in my head, but you're going to help to bridge the gap. For me, digital twins, it's in the IoT space and the IoT world. So how do you bridge that back to spatial computing?
I think that's the reason it popped into my head, was that we're talking about having to learn all of these skills. Well, if you want to start looking at digital twins and building a real project from that, you've got to start adding things. You've got to start learning devices, IoT, graph databases. There is no one person who can put these things together, and these people generally don't hang out together. So there's some form of organizational move that needs to take place to enable these things to really take off.
Is that something your team is helping our customer with as well? I mentioned at the beginning that you're part of a prototyping team. So your work is to design prototypes for customer, but the prototype, I guess, it's not only the piece of software, it's larger than that. Yeah, so
as we're talking about how complicated some of these things can be, our prototypes are typically 6-week prototypes. So, it's around, building something which is executable and useful for the business use case, yet then mapping out a path to production. Because obviously within 6 weeks, it's a limited time scope. So sometimes you might have to cut some corners around the content or somewhere else in order to be able to produce something that's actually executable and useful.
And I'll send you to the AWS prototyping page on our website.
Yes, please do. I should say, I'll give a shout out to my team. So I work with a team of about 30 of us or so. We're globally distributed. And, the problems that we work on are very difficult problems that you couldn't just pay a consultancy to go and do. So I work with a super talented team of folks who work on really interesting projects. It is a multidisciplinary team. However, I am the only one working on spatial computing at the moment, so it's a bit lonely here.
And is your team hiring? That's the next question.
I'm not sure.
Amazon.jobs, if you want to find the jobs at Amazon, all the job posting out there, Amazon.jobs. That's very easy to remember. Peter Dogintis.
That's it. Thank you.
You're a principal prototyper in the prototyping team at AWS, talking about spatial computing today in the AWS Developer Podcast. Thank you for having listened to this episode until the end, and see you next week for another episode. Bye.